Hello everyone. For this week, for our day exercises, what I'd like to do is go through some mathematical operations. We've done that a little bit already, but I want to go through them in a bit more detail. And then I'm going to give you some practice exercises, actually one big practice exercise that I want you to run through that's actually going to be a little bit more close to real world and not such academic exercises as we've done in the past. Why do we do math in R? Why do we need to talk about math in R? Well, everything we do in R consists of two things. It consists of the data that we either load in or we enter in, and it consists of operations that we conduct on that data. Now, most of those operations are functions, and they're functions that we set up and structure in such a way, and then we perform those functions on the data sets, and it gives us the answer that we're looking for. But some of these things are also simple operations, and they're mathematical operations. So far what I've had you do is load the data into vectors, and we're going to continue to do that this week. Next week, or maybe the week after, depending on kind of where we get to, I will actually give you a data file and show you how to load a data file. That's when you're going to start to see the power of R, when you actually can load your own data file and start manipulating things in your data file to give you the results that you want. That's when I think you're going to start seeing the usability and accessibility of the tool. But what we're going to do today is we're actually going to load in a couple of vectors, and we're going to play around with some mathematical functions. And this will give you a better idea, more familiarity with those functions. There are four types of mathematical functions in R. The first one is basic arithmetic operators, and those basic arithmetic operators are things like plus and minus and divide and times and stuff like that. Then beyond that, there's some more complex mathematical functions, things like absolute value and square root and stuff like that. We'll take a look at some of those. There are some vector operations, and what vector operations are is the ability to go in, once you've set up a vector, maybe it's a 1 by 100 vector, and you want to access position number 53, and you want to change it or move it or do something to it. You have vector operations that allow you to isolate a specific position in a vector and change it or modify it or do whatever you want with it. And then there are matrix operations. We've talked so far only about vectors, but data that is stored in multiple dimensions, that would be 2 by 2, dimensions 3 by 2, 4, whatever, however, it's more than just a line of data that would be in a vector. Those are called matrices or matrix. And there are some functions, mathematical functions that allow you to identify a specific element in a matrix. You'd identify the row and you'd identify the column that the item would exist in. You can do mathematical manipulation on it. So those are the four categories of mathematical functions. Today we're only going to talk about basic arithmetic and mathematical functions. Here are your basic arithmetic or your basic math. And these are pretty much as you would code them in R. You might not use X and Y unless you've assigned values to X and Y, but you can use variables, you can use the actual numeric values. But they're simple things like multiplication or addition, subtraction, multiplication, division. The last three are a little bit more complex. You can take, for example, 2 and raise it to the power of 3. So in that case, x would be 2 and y would be 3. And running that function in R would give you 8, because 2 to the power of 3 is 8. The next one, the second one towards the end there, allows you to identify what a remainder is after you've done division. So if you divide 3 into 7, 3 into 7 is 2 with a remainder of 1. So we'll just isolate the remainder. And then the final one at the bottom there really just conducts the division and drops the remainder. It drops your value down to the nearest integer. And so it's you're just going to return, 3 goes into 7 twice, and we don't really care about the remainder. So, but these are not very exciting. These are things you can do on a calculator for the most part. And so they're not terribly exciting, but still they're useful in R. Let's take a look at how we can use some of these functions. So we're going to go back to the idea of loading up a vector and using the information in that vector to conduct some functions. So first thing we're going to do is we're going to come up with a variable, a vector actually, that we're going to call units sold. And we're going to load that with the combination of those 6 numbers, actually 7 numbers, there are 7 numbers there. So that creates a vector of 1 by 7 for 7 numbers, and it contains those numbers. Let's assume that those are sales numbers, that there are 7 people, and this is the results of the end of the day, and those 7 people in that order sold those numbers each. And now what we're going to do is we're going to go through and we're going to identify how much was that worth. So as we have those numbers, if we assume that each unit sold is worth $25, then we can go ahead and calculate that out. How much did each person earn? So value sold is going to be set equal to, that's a new vector. So this is value sold as a new vector, is going to be equal to unit sold, our previous vector, times 25. And once again, we can take advantage of the fact that we can do multiple sort of cycles through a vector in a single command. And the result is what it shows there, 125, 175, and so on. So again, a single command can impact the entire vector. If we're to come up with a second vector, this is called units sold to, and we assign it those values using the combine function, then we decide that the value of each of those units is $50 instead of 25. We go ahead and recalculate out now your value of sold to is going to be set equal to units sold to times 50. Then the result's going to be 50, 100, 150, and so on. You can just see how we basically just did the same thing. We just changed the numbers. Now what we're going to do is a simple addition. We're going to add units sold to units sold to. And what that's basically to do is cycle through all 7 numbers in the first vector and add it to all 7 numbers in the second vector and give us our result, which is basically to be 7 functions of addition on the 2 vectors that gave us our result, and all 7 numbers are there. So that shows you a little bit more how we can use multiplication and we can use addition, and how the whole concept of the vector, being able to access all those numbers at the same time and perform 7 individual functions at the same time without having to cycle through it multiple times, how powerful that can be. Let's look a little more at some mathematical functions. This is the second category that we have. And some of these, I didn't put them all up there, but I put some of them up there that I thought might be useful. The first one is absolute value. So if we have, negative 25 and we put it into an absolute value function, it's going to return 25. Now, that's not terribly useful yet, but there may be functions or there may be reasons why you might want to use that. The next one is logarithm. It's a logarithmic function, and really, in short, what you would use this for is to convert where you have a scale of like 1 to 1,000 or 1 to 10,000, and you want to plot that into just a scatter plot. It's really hard to do that because the scale is so large. So you convert that to logarithmic values, and the logarithmic value actually is really kind of an exponential function. It's 10 to what power or whatever to the 10th power is going to give you that value, and it brings your scale way down. So again, probably not very useful for our purposes, but it's nice to know that it's there. Square root of x gives you the square root of x, and that is something we're all familiar with. The factorial command actually gives you some number factorial. So if it's, for example, 5 factorial, you would multiply 5 times 4 times 3 times 2 times 1, and that would be the value that would return. And then choose x comma y will return the number of possible combinations where y elements are drawn from a pool of x items. So if you have y set to 3 and x is set to 6, it'll tell you what is the number of possible combinations of 3 items I can draw from my pool of 6. Could be very useful. Maybe something we probably won't get to. Certainly we're not going to get to it in this lesson. A couple more functions. Rounding numbers. These could be very useful. For example, if I have 123.456 and I decide I want to round that, and I want to round it down to where the digits past the decimal are 2, then I can run the round command and it will do that for me. So it becomes 123.46 because it's rounding up, because 5 rounds up, of course. If I want to round it and I want to actually drop the digits, that should actually be the round 123.456, not comma 456. What I'm asking it to do is I'm asking it to get to the nearest hundreds. You could do this with the nearest tens as well with a -1. So basically the 2 corresponds to the number of digits, number of zeros. So if I'm rounding 123.456 and I say digits is equal to -2, I'm telling it get it to the closest 100, whether it's 100, 200, 300, and that's the value that it returns. Significant different digits actually allows me to identify take a number and put it into some number of significant digits. So if I've got, again, 123.456, and I say digits equals to 4, it is going to drop everything but the first 4 significant digits, and then it's going to round up on that last one. So I'll get 123.5 out of my 4 digits in my significant digits function. The last 2 are floor and ceiling. Floor, if I take 123.45 and I say give me the floor, it's going to drop it down to the lowest integer. So it's basically going to drop the decimal off. And if I say ceiling, 12345, it's going to give me the next highest integer, with also, again, dropping the decimal off. A few more. These are ones that we'll actually use, and the exercise that you have this week asks for you to use 3 of these. The first one is sum, and sum basically can take all of the numbers in a vector and just add them up. It's similar to any summation function that you might find in Excel or any other software. Same with prod. Prod, take all of the values in a vector and multiply them together. So those two are pretty straightforward and pretty easy. Min and max will allow you to read through a vector and find either the minimum value or the maximum value in that vector. Those, again, pretty straightforward, but we're going to use them in our exercises. So that's a lot of math, and I haven't even shown you the half of what you can do in R. But anyway, let's practice a little bit of this so you can get a feel for how it works. So I've given you this script. This is a script that I called Mad Math Skills. And what I want you to do is I want you to take this script, and we're going to go ahead and copy this script. I'm going to have to actually get out of it. Hold on, let me get out of PowerPoint and get access to the script. So I'll go ahead and copy this script. And I'm going to put it into RStudio. And I'll go back up to the first command. I'll run through these commands one by one. Remember, of course, that any command that is preceded by a hashtag is a comment, and so the R will ignore it. So this script is called Mad Math Skills. Basically what we're doing, Bill and Joe are running a business. Both work 5 days a week, and both sell a certain number of computers each week. First, we're going to track Bill's sales. So we're going to set a variable, actually a vector, called bills.sales to these values. We'll go ahead and run that. And bills.sales is set up. Then we're going to look at Joe's.sales, and we're going to set that vector equal to those values. Now we want to do something with this information. So we're assuming that they're making a profit of $500 on each computer. So how much money did Bill make? Well, we're going to take another vector, and we're going to set it equal to Bill's sales times 500. So it's going to take 500 times each of these numbers and pop that into this new vector called Bill Money. And that's done. Okay. Well, let's see if it worked. We'll go ahead and do print the vector Bill Money. Looks like it worked. Let's go ahead and add up all that Bill made that week. Sum Bill Money equals $13,000. And let's find out what is the minimum day that Bill had. What is kind of the worst day that Bill had? And Bill's worst day was $1,500, which looks like it was Thursday of that week. Okay. We're going to do the same thing for Joe. We've set calculated Joe's day-by-day profits. We'll print out what we found. Okay. What was the total for the week for Joe? $13,500. And what was his worst day? $2,000. The worst day? Thursday. Must have been something going on there on Thursday. Okay, well, who made more? If we look at the results, we see that Joe actually made more. He made $500 more, so he's slightly ahead of Bill. Okay. Well, what did they make together? Now what we can do is we can take Bill Money and Joe Money, and we can just add them. Very simple addition function. And what it does is it goes through item by item and it adds them up. So you can see the vector now is a combination of Bill Money and Joe Money, and it shows you the total values in those vectors. What did they make together total for the week? So what we're going to do is we're going to sum. This is a function with an operator. We're going to sum Bill Money plus Joe Money. The first thing it's going to do is perform what's inside the parentheses, and then it will look at the function. So we'll go ahead and do that. Together they made $26,500. All right, well, let's do a plot. Let's take a look at a plot of Joe Money and Bill Money and see what that looks like. And there's our plot. So we can look at for each of the days, these are not labeled very well, but we see Joe Money plotted against Bill Money, and we see for each of the days kind of how they compared. Pretty simple plot. And then if we wanted to actually save that plot, we can go up to the export command here, export it as an image, and copy it actually to clipboard, and then be able to paste it in any document that we wanted. Okay. Going back to PowerPoint, we already did that, so I'll skip that slide. Here is your assignment. This is what I would like you to do. And it's a 2-slide assignment, so it's a big one. Here are your parameters. You have 3 salespeople at a wine store, Jack, Ruby, and Beth. You've got Jack's sales there. Those are the number of bottles he sold Monday, Tuesday, Wednesday, Thursday, and Friday. Okay. And for each bottle of wine that he sold, he earned $5.35. Ruby's sales are there listed Monday through Friday, and here's what she made for each bottle of wine. Beth's sales are there Monday through Friday, and here's what she made for each bottle. Okay. Your ultimate goal is to come up with how much did the wine store earn for that week. Okay. I want you to show me in R, similar to the script I just showed you. I want you to use comments to tell me what your actual commands are doing. Then you can either copy and paste your R script into an MS Word document and also show me your results so that I can see that the commands actually work. Or you can go ahead and run everything like I just did in RStudio, do an alt print screen, and then dump the results of your alt print screen into a Word document and turn it in like you have been doing. So this is just the first part of the assignment. In the second part of the assignment, what I'd like you to do is a couple more mathematical functions. So once you've identified the total sales vector, because you're going to have to do that in order to come up with the sum. Once you've identified the total sales vector, what is the average sales for the week? Well, what is the mean? Use the mean function to determine that. And then also tell me what is the median sales for the wine shop for the week. So Monday through Friday, what is that median value? Okay. What is the wine shop's best day? So you're going to use the max function for that. And what is the wine shop's worst day? You'll use the min function for that. So put those four results, the mean, median, min, and max, also into the Word document that you'll be turning in. Then we're going to go on and do some plots. So I'd like you to plot Jack's sales for the week against Ruby's. Use the plot function that you saw in the previous script. Capture that plot and put it into your Word document. Plot Ruby's sales against Beth's. Capture that plot and put it into your Word document. And then plot Jack's sales against Beth's. Capture that plot and put it into your Word document. Then go ahead and save off your Word document and submit it as your submission for this week's weekly assignment. So I'll go ahead and be able to look through that and see what you've done and see if there's any questions or concerns or comments that I can give you feedback on. Okay. And lastly, I already said this once, but I'll say it again. Remember to put comments in your script so I know what each line of your script does. Okay. If you have any questions, I'm accessible on email. Just go ahead and send me an email and I'll try to help you out. All right.